What if I told you that the most powerful scientific instrument ever created isn't a massive telescope or a particle accelerator? It's something you have right now between your ears. It's the human imagination. For centuries, the biggest leaps in science didn't start in some fancy lab, they started in a mental one. And that's exactly the tool we're going to dive into today.
So think about it. If you're Isaac Newton, how do you figure out how orbits work? You can't just, build a giant cannon on a mountain and shoot something into space. Or what if you're Einstein, trying to understand the speed of light? You can't exactly catch a ride on a light beam to see what it's like. This is the exact problem that geniuses have wrestled with forever. So, how do you test the untestable?
Well, the answer is something called a thought experiment. And it is such an elegant, brilliant solution. You just build a scenario in your head, you follow the logic, you see where it takes you, and you see what you discover. The source material for this calls it a laboratory of the mind, and that's the perfect way to put it. It's a place where the only limits are your own imagination and reason.
All right, so here's our game plan. We'll start in the mind's laboratory, then look at some ideas that literally change the world. We'll break down the 4 main ways to run these experiments, and then I'll show you how to build your own. We'll even run a test in a modern workplace setting, and we'll wrap up with how you can start to think like a genius.
Okay, Section 1, the mind's laboratory. Let's really dig into what makes this mental tool so incredibly powerful.
The real magic of a thought experiment is just how free you are. You're not tied down by budgets or equipment or any of that. You can play with a nearly infinite number of variables just by, thinking about them. And because it's all happening in your head, you get to sidestep all the complicated ethical reviews and legal approvals, which is a huge deal. The only thing it costs you is a little bit of your time and your brain power.
All right, Section 2, Ideas that Changed Worlds. Now for the really fun stuff. Let's look at some of the greatest hits from the history of science.
Look at this. These are some of the most world-changing experiments ever, and they all happened inside someone's mind. You've got Galileo, way back in the 1500s, mentally dropping cannonballs off the Tower of Pisa to poke holes in Aristotle's physics. Then Newton imagines his own cannonball to visualize how orbits work. Einstein pictures himself riding a beam of light, a key step towards relativity. And of course, Schrödinger's famous cat wasn't real. It was a mental puzzle designed to show how weird quantum mechanics was. These were not just daydreams. They were focused, disciplined exercises that completely reshaped reality.
Now, you might be thinking these are just random flashes of genius, right? Well, not exactly. It turns out there's a structure to it all. The source paper actually organizes them into a really clear mental toolkit.
And it all boils down to 2 key questions. First, look at the columns. Is the theory you're testing brand new, or is it already well developed? And second, look at the rows. Is your goal to confirm the idea, or are you trying to disconfirm it? That little grid gives us 4 distinct types of thought experiments.
So a type 1 experiment is what you do when you have a fresh idea and you want to kick the tires a bit, see if it actually works. This is exactly what Newton was doing. His theory of gravity was still pretty new, and that cannonball experiment helped him build confidence that he was on the right track.
A type 2, on the other hand, is basically a stress test for a new theory. You're actually trying to break it. See, Schrödinger wasn't a huge fan of this new idea called the Copenhagen interpretation of quantum mechanics. So he designed the cat experiment to create a paradox, this impossible cat that's both alive and dead, to show just how absurd he thought the theory was and force people to rethink it.
Okay, type 3 is for when you're going up against an established idea. For centuries, everybody believed in Aristotle's theory of gravity. Galileo's thought experiment wasn't just about his new idea, it was about exposing the deep, fundamental flaws in that old, established model.
And finally, we have the giant killer, type 4. This is what you use when you want to take down a really mature, well-established theory. The emission theory of light was a big deal in physics. But when Einstein imagined writing that light beam, he created a puzzle that the old theory just couldn't solve. He basically broke it, and that paved the way for his own revolutionary ideas. So you see, it's a tool that can build, refine, or totally tear down theories.
So that's the theory, but how can we actually use this?
Well, the source material gives us a super clear decision tree to follow.
First things first, you need a target. This isn't just about aimless daydreaming. Your experiment has to be focused on one specific idea. Are you trying to prove a new business strategy will work, or maybe disprove a long-held belief about your customers? You've got to know exactly what you're aiming for.
Once you have that goal, you have to become a storyteller. The source calls this being a raconteur. You build a simple but compelling narrative that makes the abstract idea feel real. Remember, Newton didn't just think about formulas. He pictured a cannon, a mountain, a soaring cannonball. That story is what makes it all click.
Okay, with your story in mind, you circle back to that grid we talked about. You have to figure out how mature the idea you're testing is. Is this a brand new concept, or is it a deep-seated belief you're trying to challenge? That's going to determine the whole context of your experiment.
And finally, what's the end game here? Are you trying to build a case for this idea, or are you playing devil's advocate and trying to find the holes in it? This last question really clarifies your purpose and tells you exactly what kind of experiment you're running, whether it's a type 1, 2, 3, or 4. So you put all those decisions together and you get this simple 4-step process. 1. You plan. Set the scene. Lay out your assumptions. 2. You execute. Build that story, using what the paper calls disciplined imagination. It's creative, yeah, but it has to be logical. 3. You report. Based on your scenario, what's the outcome? And finally, 4, you discuss. What's the big takeaway? What new insight did this just give you? Now, to see how this works outside of physics, the source paper actually applies this whole framework to a really modern issue, workplace allyship.
So here's the scenario. You've got a senior male department chair who wants to be an ally for a junior black female colleague. She's having a tough time with the tenure process and asks him to take some very specific actions to help her out. But he's worried that the things she's asking for might actually backfire and hurt her career. So now he has this dilemma. Does he do what she asked for, or does he do what he thinks is best? And when you run this thought experiment, a really important tension comes to light. If the chair acts on his own judgment, he risks what we call performative allyship. He's basically taking away her agency. The experiment reveals that for allyship to be effective, it has to be driven by the needs expressed by the person you're trying to help. The big takeaway is that the value of the support is decided by the beneficiary, not the ally.
Okay, last section. Think like a genius. Let's pull this all together and talk about how to make this incredibly powerful tool your own.
So why does any of this matter to you? Because this isn't just a trick for physicists. It's a tool for anyone who wants to solve difficult problems. It's a way to sharpen your ethical reasoning, just like in the allyship example. It forces you to dig up and really question your own hidden assumptions. And ultimately, it gives you a practical way to practice that incredibly valuable skill, disciplined imagination.
This quote from the source material just nails it. Thought experiments are the bridge between the abstract and the concrete. They take these big, fuzzy ideas and make them real, tangible, and testable, all through the power of a good story.
Look, we all run on assumptions about our work, our relationships, our beliefs. The only real question is, which one are you going to put under the microscope? What experiment are you going to run in the laboratory of your mind today?